Okay, moving right along. Our first speaker for the first panel of the day on materiality is Charlotte Erckrath, who's at the Bergen School of Architecture. Welcome, Charlotte.
Hi, everyone. Thanks for having me here today and for this opportunity to present my work. Thank you very much, Nat, for this fantastic talk. And yeah, I don't know what I can add to that, if anything at all. I try to do my best. The title of this presentation is Ambiguity and the Agency of Drawing Tools, with the focus on the exploration of the potentials for an immersive spatial experience through an expanded idea and application of drawing tools. This work is part of a broader multi-layered project that branches out in various ways. Caspar David Friedrich's romantic painting, Wanderer Above the Sea of Fog, holds a desire to be involved and immersed in a spatial experience. This desire stimulates my fascinations and struggles with the contradiction that lies in the architect's ambition to work with an embodied spatial reality, while the means for drawing rely on autographic projection, a drawing convention based on an abstract spatial model. This project takes a closer look at the realm between the inhabited experience space and autographically projected space, with a focus on its ambiguities and contradictions. Sorry, just trying to start my timer. This Baroque example, San Carlo alle Quattro Fontane by Borromini, makes evident how much potential there is in the play with geometries that seemingly encourage linear perspective, while at the same time negating it through emphasizing volumes and masses. Umberto Eco calls the Baroque space an open work that allows new experiences every time through multiple shifting possibilities of interpretation. Verflin calls it painterly and says the space is set in movement. It is such qualities that this project seeks to engage with through the development of drawing tools. The plane table establishes a drawing plane as a datum to receive the plan drawing of a surveyed landscape. With an alidade, directions are cited and distances are measured and plotted. Thus, it situates the draftsperson both within the landscape and within the drawing. So yeah, so here you find the reference point. What we know today as 3D scanning or photogrammetry software has its roots in an application by Émile Ossédat. Around 1850, he combined the plane table with a camera lucida, which projected the view of a facade onto the plane table. This enabled the draftsperson to interact with the drawing and the spatial experience simultaneously. In such a way, the camera lucida and plane table provide a direct embodied link between the observed space and the represented space. Ossédat subsequently constructed a reverse perspective to receive an undistorted measurable plan of the facade. So it's hidden here. I tested this method on this example of Helmut Newton's photograph, self-portrait with wife June and models, as a speculation on the space of this image. I mentioned this earlier study here as it sets the ground for a specific spatial inquiry. The semiotic content of this image has been discussed elsewhere, and for this study, the image shall serve as an example for potential spatial tool set that engages critically with limitations of autographic projection. My perspective analysis shows that Newton employs subtle alterations to conventional spatial expectations, small tweaks and irregularities, as well as a careful composition with strategic covering or framing of specific elements to enforce an ambiguous perception of the image. The puzzling existence of multiple contradicting vanishing points are particularly interesting in combination with items that slip the reverse perspective. In this case, the bodies and garments, as well as the space in the white backdrop. Constructing the reverse perspective makes evident where linear perspective operates most efficiently. Defined geometries and reappearing items of visually comparable size, outlines, parallel lines, and patterns that correspond to vanishing points encourage not only pictorial depth, but also they can be applied to inflict contradictions and ambiguities. The camera lucida was employed in this study to engage in a dialogue with the space of the drawing and the space of the model. The model is the result of the reconstruction of mirror and floor space, including the perspective shadow of wife June on the floor. With the distance from the model to the camera lucida, the scale of the perspective can be controlled and thus linking directly to the reverse perspective drawing that I showed earlier. This arrangement is still fundamentally based on orthographic projection, which favors distinct geometries and does not embrace nonlinear geometries. With this method, these can only be efficiently captured in abstracted, flattened outlines. In using the camera lucida, the effect of a constantly moving focus in the spatial perception of the model becomes evident, causing this projection to distort. As a consequence of conducting the speculative analysis, I work further with the hypothesis that the interaction of linear and nonlinear geometries provide a potential source for perceptual ambiguity. Nonlinear geometries hold a long history in visual arts and perspective representation, beginning with the earliest mention of linear perspective. Mark Dorian has pointed to the mirrored clouds in the perspective construction of the Baptistery in Florence by Filippo Brunelleschi, stating that they form an outside of the space of linear perspective. Andrea Pozzo's example of a space combining linear perspective construction with an intense place of nonlinear geometries. In some instances, utilizing pairs of vanishing lines to enforce depth, and in other places, bringing the space into play with seemingly floating bodies, garments, and clouds. This is a fresco painted on a vaulted ceiling. Landscape gardens should be mentioned, where comparable visual principles are utilized. Here in a plate from Hints on Landscape Gardening by Pückler Muskau. In Newton's photo, the garments covering the floor may function slightly like scattered trees on a lawn in a picturesque landscape garden, usually arranged to blur the boundaries and staggered to give a sense of a deep space. Here, the garments occupy the floor and covers the spatial depth that it would otherwise hold. In addition, it emphasizes the boundary with the backdrop. The first attempt in engaging with these geometries looks at how the depth in these forms could be measured and drawn in an orthographic projection with the aim to translate between the visual appearance and projection drawing, while expecting these would be much like topographical maps. This first drawing tool departed from the idea of a plane table with an alidade. In order to measure the distance at the same time as the angle of direction, this new alidade has two viewing axes, one for each eye to be looked through simultaneously. Value is given to working with an embodied relationship, and hence the viewing axes are dimensioned to my own eye distance. In order to diminish imprecision from narrow angles, the tool is designed to cover a working area of an A2 sheet. It is constructed to align the side edges with the target. Here you get the side edges. A parallel displacement constructs an intersection. Down here you have the parallel displacement, and here you find the intersection, which is scaled with pantograph to obtain a one-to-one drawing. So down here is the element that is the pantograph. The first version revealed challenges to obtain a precise enough visual alignment with the point on the object. This was solved in the second version by working with aligning techniques that allow the eye to focus on the target while the alignment device remains out of focus. Limiting the visual range with a tube here allows seeing the two sight rings within each other, thereby keeping the sight line. The tool has taught me visual understandings that remains important throughout the study, in particular the experience of exploring the possibilities and challenges around focusing. It makes evident how our perception can never keep different distances in focus simultaneously. The tool has further unwanted implications, for instance, the loss in mechanical movements. However, the main reason for not pursuing the development further was the realization that instead of closing a gap, the tool required to fragment the object into measurable points, which did not enable an embodied visual experience while drawing. Edouard Gaston de Ville has published an overview of the field of photographic surveying in 1895. He mentions perspectographs as a possibility to reverse construct plan drawings from perspective by a mechanical translation. The idea that one could follow the outline of a river in an image and receive an undistorted measurable plan seems still fascinating if instead of a two-dimensional image, one could refer to a physical model more directly. De Ville not only mentions Lossidart's Lucida plane table, but also evolves the principle further through the Wheatstone stereoscope. As one of the first to integrate binocular vision, this device makes use of the eye's capacity to measure depth through parallax, similar to photogrammetry applications today. This setup broadens the application to the possibility of surveying landscapes. The viewer sees each image with one eye similar to an ordinary stereoscope. So here is the eyepieces that you are viewing through, and with the help of two mirrors, you see with each eye these different, this set of stereoscopic pictures. Small differences in the location of details in a set of two pictures enable to see a measurable stereoscopic image within the space in front of the viewer. So the stereoscopic image appears here in this area. A drawing tool that holds a floating mark is moved within this space to trace the topographical contour lines. This new drawing tool is based on this principle and replaces the images by the view of an object. The resulting hologram is photographed here through one of the viewfinders. It shows a model of the garment on the floor in Newton's photograph. The hologram is located above the object on top of the drawing plane. The dimensions of the drawing tool are suited so that the hand can reach the tangible holographic model, meaning that visually it is possible to distinguish the location of the surface and touch it. The diagram shows the path of optical reflections. The eyes are looking straight through the camera. So you get a set of clear glass to look through directly into the space where the hologram is appearing. While the image of the model is reflected first by a mirror and second by this glass screen. So down here you see the object reflected in the mirror, and then the image of the object is reflected onto this glass screen, and this is how you get a hologram. This glass screen allows to see the reflection of the model in the space of the drawing at the same time. The camera is built as a prototype and the mirror and glass should be replaced with optical glass and front-side mirror to avoid a double image, resulting currently in a blurry experience of the model. The garment is brightly lit, while the space of the drawing as well as the visible side of the pencil holder is black. This supports a better visibility of the hologram. The white point on the pencil holder thus floats in the drawing space. The light situation greatly affects the impression. As an example, here the pencil holder directed towards the light reveals it as an object inside the hologram. Turned away from the light, it hides itself and enables the white mark to float. The drawing shows a very tactile process of aiming to move the white spot in the surface of the garment. The resulting section line is not complete, since the surface is not continuously visible from the angle of view. Situations where the surface folds and disappears cause moments of doubt in the drawing. The edges that appear between what is in front and what is in the back seem neither in one nor in the other place. The dark areas in the garment do not reflect any light. Thus, in the hologram, these areas are not tangible. They appear as holes in the surface of which the depth cannot be perceived. Areas with subtle gradients offer only vague cues for the eyes to recognize a precise position, while closer to edges and details or patterns, the coinciding of marker position and surface become very clear. The drawing space becomes a stage that encourages to play with a hologram in an intuitive manner. On the left, an image through the viewfinder, and on the right, a view of the drawing plane with the items that entered the holographic field. Folding up the drawing plane allows to trace a section of the model on an upright paper. This section is reintroduced to the drawing to engage spatially with the garment. The parts of the section that are incomplete are speculated upon and adjusted to the view. Here, the section begins to follow the visible contours. A pattern helps to encourage depth perception, but also makes room for twists and unexpected situations. Working with the camera provides a tactility to the depth perception. The understanding of key parameters in visual experience become perceivable through an expanded toolset and therefore available in a more conscious manner. It remains to be tested how this tool allows drawing what is factually there or what is perceived. The next step in evolving the tool further resides in making the space and drawing available in movement, as well as aiming for a slimmer design, for example, employing prisms instead of mirrors to enable a closer engagement with the space. Furthermore, the intention is to conceive and design immersive spaces with a technique. Thank you. So this one is supposed to be looked through from the top, and then it shows you the space inside, in front of you, sorry, while projecting down onto the drawing surface. And it favors certain light conditions, obviously. Like it likes the object of projection brightly lit. So if you're looking to something bright, you would get a better reflection.
Questions, comments? Yeah.
Okay, I don't know, Charlotte, if you know the perspectograph, the invention is Lambert in the 18th century, about 100 years before the one you showed.
that may well be.
Yeah, the interesting thing about this little piece of information is that Kant took it very seriously. Like, he really admired Lambert, because Kant believed that we have in our mind kind of a priori space-time that allows us to see in perspective.
I think is it in the book, in the Perspective Hinge book?
Yeah, we'll talk about that.
It's a panoramic version of, isn't it?
Well, no, not really.
No.
Lambert wrote a book called La perspective affranchie du plan géométral, where he basically was arguing that you could draw perspective without having nothing to do with plans, because perspectival condition is true. The truth is optical. Now, this is not only for you, but it's for everyone that is interested in picture planes, right? Because you can use picture planes differently. But then if you fast forward like to the 1920s, you get Marcel Duchamp, who is very important for architecture, precisely for having said that, declared the end of the optical paradigm in picture making, right? So I don't know where all this puts us, because in many ways, working and playing with these things, of course, can take you beyond the banal perspectivity of the past. But I'm just mentioning this because I think one should be very aware of how this has changed the playing field when one talks about picture planes or these devices, you know, like the camera lucida. But anyhow, it's very fascinating.
I'm a great admirer also of Duchamp's work, and I have looked carefully at those that have dealt with his very important works. And there is also obvious references between the photo that I'm using, the Helmut Newton photo, and Duchamp's work. Yeah, that's some of the other layers that I'm dealing with in other parts of my work, which you don't get a glimpse of here today.
There's a question at the more friends at a distance. Ah, tiens, c'est Carole. Charlotte, it's interesting to see your work in Nat's one after the other. Where Nat spoke about the dioramist perspective, you speak about the vanishing point as a source of geometry, where his machines act with chance, yours are highly controlled and plays the eyes as the measuring datum. I can't help to wonder how to reconcile the two, how to measure yet to allow the experience to be accounted for. Sorry, I don't mean to compare the two. I am genuinely wondering about how to record the experience well.
How to record?
The experience.
Yeah, that is a big problem. How can you record any experience? I mean, what you see, what I'm showing here today doesn't in any way allow you to engage with the pleasures that I have when I look through that and move the stuff around in my hologram. so yeah, it's a big problem. And also, like, the tools that I'm working through, the photo of Helmut Newton is a two-dimensional thing. It's not spatial. And the things that I'm trying to tease out, which is the spatial ambiguity, I only ever imagine through the knowledge that I'm gaining. I haven't been to Fontana. I'm just imagining how, through the knowledge that I'm getting from how these geometries are operating, what kind of subtle sort of spatial experiences and ambiguities they construct. So, yeah, I'm working with these, or I'm trying to. The ambition behind making this tool is to work with these conditions simultaneously. Yeah, if that answers the question at all. And I'm sorry, I don't have the project here yet. Yes.
I think it definitely starts to answer. Mark, were you? You want? Yeah, just a comment.
Thanks, Charlotte. I was just wondering, it's hard not to think of Las Meninas with the Newton photograph, and to feel in some way it's a reperformance of that or a kind of translation of that. And I wondered if you had any thoughts about that.
One of the ideas in pursuing with this photo are actually coming from Anna Maria Rabe, who writes about the space in the painting Las Meninas. And she actually describes the idea of the open work there. So yeah, that has set me on the path of like, oh yeah, it's this idea of the open work and it's this idea of ambiguity. And I have in another talk where I enlarge more on the photo, also talked much more about the idea of ambiguity, referencing to Emerson, and his ideas of contradicting concepts that allow ambiguity to arise. And the idea that I'm working with is that there is that space of linear perspective, which in a very specific way enforces depth perception. And then there is that space of nonlinear perspectives that give a very different spatial experience. And I think that in that, like teasing out a contradiction between those two, and this is, I think, what Newton is doing, very subtly hidden, like Shakespeare. Yeah, that is where that is a type of ambiguity that I'm seeking for. Yeah.
Thank you so much, Charlotte. We'll move on, and thank you for your talk.
Thank you very much.